we will now look at the shortcut for square root of perfect squares of two-digit numbers. So if there's a two-digit number, you've made a square of it. So I'd ask someone to do it. They gave me this number. Then there is a method in which I look at the ones and I say, okay, you know, this ones can only be, you can only get 6 in the ones place if it's a perfect square, not if it's not a perfect square. Then you can, if you get 6 in the ones place, you either have a 4 in the ones place or you have a 6 in the ones place. And if you have a 31 in the hundreds place, then it means that it's more than 2500. 2500 would have come from 50. It's not 3600, so it's not become 60. So this number of hundreds tells me how many tens there are, and then I can figure out that that number is either 54 or 56. Now there is a shortcut for all squares that come as which have 5 in the end, right? That you can just write 25 and then you can multiply 5 with 6. So that's going to be 30. So 3025 is the square of 55, that we know. So then you see, is this number more than 3025? Or basically you look at 30, that's enough. So is this number more than 30 or less than 30? Right? So if the number is more than 30, it's a bigger number, which is 56. Yeah. So what does this mean, right? So let's first figure out if you have, what is the smallest number, right? So 10 square is going to give you 100. So if the perfect square has to be more than 100, that's what it means, right? And now if you look at 99 square, right, I have made another video already. I have made a video already about making squares, right? So 99 square is going to 81 here, 81 here, 99 the 81, double of that 162. So if you add it, you get basically 9801. So essentially what we are saying is, if it is between 3 digits and 4 digits, because I almost reached 99, so let's say yeah, it's like 10,000. So basically if it is within 100 and 10,000, in fact this number precisely, you are going to get a 2-digit number as a square root. So you can take a square root of that number if it's a perfect square. This is where you can use this method. You cannot use this method if it's beyond. You cannot use this method if it's below. You need to do something else to reduce it so it comes within this range. So that's the first thing. What is the range in which I am using this method? So it must be clear that I am looking at how many hundreds are there, and I am looking from 100 all the way up to 98 hundreds. I can use this method. Okay, that's the first thing. Okay, next we'll look at why does this method work. So if we look at 1 square, 2 square, 3 square, 4 square. So you remember in the ones place, yeah, when you square this number, the ones place will be determined by the square only of the ones place. So if you look at that here, I have also paired it so that you can obviously see that if I have 1 in the ones place, it can either come because of 1 or 9. Yeah? If I have 4 in the ones place, then it will either come because of 2 or all the way down 8. So it's all pairs around 5, right? So if it is 3, then it is either 3 or it is 7. If it is 4, it is either 6, it is either 4 or it is 6. And of course 5 will have its own 25, it is not paired, right? So this is the combination that can give you. So one interesting thing here is, first thing you can notice is, if you have a 2 in the ones place, it's not a perfect square. If you have a 3 in the ones place, it's not a perfect square. So these two are completely ruled out, right? So 3 is ruled out, 7 is ruled out. So what are the numbers that are ruled out? Let's write those down, right? So we don't have any 2's in the ones place. We don't have any 3's in the ones place. We have a 4, we have a 5, we have a 6, we don't have a 7. And we don't have an 8. So these 4 digits cannot come in the ones place in a perfect square ever. Not just 2-digit numbers, any number. Because if it was there, then some number has to be in the ones place in order to square it to get that, right? So not possible. Everything else will come tens and so on. So this is only going to be governed by this guy. Everything is going to come shifted. So never in the ones place in a perfect square. So that's a pretty neat way of knowing, can this number be a perfect square? If someone gives you that, just look at the ones place, first thing you can eliminate. If it isn't one, or if this is one of these 4 digits, it's not a perfect square. You cannot use this method for that. Okay, and now since we talked about 2-digit numbers, we are also saying that you will have 2-digit numbers will be tens and ones. So you have 10 square, 20 square, 30 square, and so on and so forth, which will have the same numbers at the front. So you have 100s, 400s, 900s, 1600s, and so on and so forth. So okay, so if we look at this, it's the same numbers and number of hundreds. So that's important, because when I get a number, I'll always look at how many hundreds does it have, and I'll compare where it fits, which is what I had done in the original example here, right? I had a number, I said 31 hundreds. So if I know how many hundreds, then I can say, okay, 50 would have given me 2500, 60 would have given me 3600. It's between 50 and 60. The number is between 50 and 60. And then I'm guessing it's either 4 or 6. And then I'm figuring out what I already showed. I multiply 5 times 6. If this number is the same or more, then I take the bigger number. Otherwise, I take the smaller number. That's it. So this is what is this method. Yeah, so in this method, you take any number, and we'll take a few examples quickly and see. I have been given a number 7569. So the first thing you have to do is you have to see how many hundreds are there. So this has 75 hundreds. Okay, and 9 is in the ones place. Now if 9 is in the ones place, we know that it's either 3 or the ones place is either 3 or 7. It will always be mapped, no? Both sides, yeah. And then I'm looking for 75. I know it's more than 64 but less than 8100. So it's in between these two. So I'm basically talking about a 83 or 87. And then again the same thing, I do 8 times 9, 8 9s are 72. This number is bigger than that, so this is the bigger number. Okay, now next number I have been given is 4761. Of course, I should check my answer. Once I get this, I should check if it's a perfect square, because it may satisfy the rules, but it may not be a perfect square. So I should always check. Okay, so now I have been given 4761. Okay, so again the same thing, 61, 1 is in the ones place, or the 9 will be in the ones place. This is 47. So if I look at 47, it is between 36 and 49. So this is actually 60. Now, I mean, this is a very easy case because it's so close to 49 that it is this one. I don't even have to multiply, check, and do anything. It's such a large number, right? So close to the next number, which would have been equal to 4900. I don't even have to check.